Welcome to episode 157 in this series where I am programming an NES game live on Twitch from scratch. Let's get started. That was the third time I've done the intro. So Thomas, no, I did not update Tiger or whatever you call it to the latest version. I'm sorry, I did not get back to you on your comment on YouTube. I will share the changes that I implemented. They're pretty small. I don't know, is there a version embedded in here? I don't think so. But I will I'll share those files because they're pretty minor, but I think you were trying to do the same thing as me in terms of including an indexed version of the image buffer in your code and having some problems. So at least it can give you a sense of what I did, and then if it needs to be adapted to the latest version. I actually don't know where the latest version is because I thought I remembered that it was forked because it was no longer being maintained by the original developer, but I could be misremembering because it's been a while since I've looked at this code. Top of the C file has the version. H version has the version. Oh, it's 1.3. So were you saying it's 1.5 is the latest? This is 2.2. So I guess it is Tiger because it's tiny graphics library. Well, now, and I guess the paw should be a hint there. But I thought, well, anyway, so this looks like a much more recent version than 2.2. GitHub only has 1.5. Okay, well, I can compare this to this version later and see what the differences are. We can always bump this up to the latest version. I don't know that there's much that we need that's new. I know there had been an issue with Mac OS at some point where, yeah, I'm pretty sure it was with Mac OS where it was not intercepting something properly, and so it was making sounds on terminal apps even though it shouldn't be. I wonder if that was fixed. Probably. So the author added that a metal implementation should be done. But anyway, that's not why we're here today, but that is useful to know. So thanks for asking. I will get that taken care of at some point here soon, just to kind of keep it up to date. That's one of those things that's kind of tough, like when you're working on a project where keeping it up to date is really not, it's not super important, because it's not like if you're working on something for like your day job, most likely you're building a product that is used by customers and you're using third-party libraries or packages that, you know, have potential security vulnerabilities. And so you want to stay on top of, you know, whatever the latest version is, because there are always new vulnerabilities found. But with this, it's like, you know, if it's working, why do I need to change it? But I'm curious to see what was actually done that that might potentially benefit us in terms of like what's actually changed. So anyway. Sorry, this is going to be a little bit more rambly, I think, tonight. I'm going to try and keep this relatively short because I'm exhausted, because, like I said, I was up early yesterday and out late coming back, and it was a long and tiring day. But let's talk about this. This is cool. So we had, in the last stream, done a lot of work reorganizing the code and switching to all these includes so that we have our code separated out, so that now, instead of having a ton of code like we had before in this area here, we have mostly some calls to some subroutines, right? I mean, there's still stuff that's just written out that we could probably turn into routines instead of having them be just kind of loose code, but nothing that I'm super concerned about right now. One of the things we talked about was, areas like this where we have this code and, we're doing a lot of comparisons to see if it's a particular value. And if it is, then we're going to go to a label. It's even more problematic in this area here where we're processing, game entities. It starts to get pretty big pretty quickly in terms of these areas where we're checking and then we're calling this code for these functions for doing the updates of the different entities in the game. And so the RTS trick should help us condense that code down to be a little bit simpler. So I think let's start with a simple case here, because I'm not familiar. I've never done this in my own code before. Conceptually, it's very simple. Let's talk about it conceptually for people who might not understand it, because it is a little bit tricky, but it's actually really cool. So as your code is going along, you have your program counter, which says, whatever address you're at. So like 8023, right? That's the location. This is the location that the CPU is looking at for its next instruction. So, it would be LDA 80, and then it does a bunch of other stuff, right? Now, at some point, you're going to get to some code where you call JSR and some subroutine. So like, wait v blank. I'm just abbreviating because my handwriting is terrible, so it's just easier to do a shorthand here. So wait for v blank, right? So what that does, and we talked about this last time because we were accidentally clearing out the stack. The stack is at location 1FF, and it's, so if you have these memory regions, right, you have the memory region that starts at 0, 0, 0 and goes all the way to 0FF. I'm drawing this kind of backwards from how this is. Let me do it. Let me do it the other way I was doing it, because it'll make more sense. So we're starting at address 0000 to 00FF, right? And that's 256 bytes. This is the 0 page, right? That's our first 256 bytes of RAM. And it's the 0 page because the first two digits here are 0. So what's nice is that you can write instructions that reference this, and it's much faster because it just has to read the 1 byte instead of 2 for the address. So then we have this next section here where we start at 100 and we go all the way to 1FF. And the stack, the NES stack pointer, is here, right? We initialize that. We have some code in the beginning that we wrote where we load X with the value FF, and then we do TXS transfer X to stack register. And there it is. It's just 1 byte. It's just FF. It always starts at the 0, 1 page. So you can't change that and move that around. And so when you do a push or a pull, like using PHA or PLA, you're pushing a byte onto the stack. So just imagine that there's all these bytes here, and because it's a stack, you're going down the stack, right? So the first byte you push in goes here. Let me change the color. That's not much of a color change. The first byte you put in goes here. Then the next byte you put in goes here. The next byte goes in, you put here, 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 right? At some point you could go down to where the stack is 0, and that will trigger a buffer overflow, because you basically are going to loop back around, because 0 minus 1 loops you back to the FF, and you've run out of stack space. Probably more likely you're using some of the space in here for data if you're not careful. And so you are now overwriting your data with stack space, stack information, which is problematic. So what goes on the stack besides just random bytes? Obviously, if we need to save data and we don't want to use a variable for that, we can push it onto the stack if we know that we're just temporarily storing it. Like if we have something that's in the A register that we know we need later, and we need to use A for something else temporarily, we can push the value onto the stack. And then when we're done, we pop it or pull it off the stack and it disappears. More frequently, if you're using subroutines, what gets stored is an address in 2 bytes. So you get this and this. And the address is your current address of the instruction that you're on, or sorry, what is it? It's the address of the next instruction minus 1. Let's go to the article, because this is where I'm comes to this address plus 1. The address of the last byte of the job subroutine that is the next instruction minus 1. The address is the last byte of the JSR, that is the instruction minus 1 is pushed to the stack. And the program counter comes to that, and then, okay. Right. So yeah, the address minus 1 gets stored, and then when you use RTS to return, it pops this off, adds 1, and then the program counter increments and you go to the next instruction that you were at. So if you look here, here's our JSR to 8000. 8000 is here. It does what it needs to do. Then it does RTS, and then it comes back here, right? And how does it know to come back there? Because when you call the JSR, it stores the address minus 1 on the stack. RTS pops that off. It pulls that off the stack, and then goes to that location plus 1. So it's going here, but then the program counter increments, and you're now on this instruction to read, decode, and execute that instruction. How does this relate to what we're trying to do here? Well, so what you can do is you can actually store any address in the stack and use RTS to execute that address, to jump to that address and execute, right? So I could take this value of 8023, store this into the stack, and then execute RTS, and it would go to 8024 because it's the address plus 1, and start executing whatever is there. So the RTS trick, basically, we're going to create a bunch of lookups for things that we want to run, subroutines we want to run based on data, and rather than based on code that's evaluating a condition and then branching based on the condition, and use that to jump to that location and then come back and finish executing the rest of the loop for the game. So hopefully that was a clear explanation of how that works. I mean, we're going to actually do this so you'll see it, but I think I explained that clearly without stumbling too much, despite how tired I feel right now. So what I want to do is I want to look at our GameState information here, the definition of the different game states we have, because that's going to inform how we're going to store the information about the subroutines that we're going to try and call. Right now, they're not subroutines. We have, you know, a title screen. It's just code, right? And then when it's done, it jumps to wait for draw to complete. We're going to turn that into a subroutine. So we'll do that with the load title screen too, but here are the different states. There's load title screen and title screen. So let's start by putting this together so that we can actually call these based on whatever the numeric value is as our index into a table of addresses. So we don't even know, like in the code, it won't directly reference calling the subroutine that's relevant. It's going to just call it based on whatever the value of our current game engine's game state is. So that'll really simplify the code, because we'll know there's a one-to-one correspondence between this value and the entry in like the table we have to create here, right? Just like they have here. And then the code to call it is just literally going to look up into that table and execute using the RTS trick. So GameState is going to become our index into this table. All right, so I think the first thing we probably need to do is we probably need to... Okay, so load title screen is already a subroutine, so that makes it easy. So let's see here. We have to create something that's a table that holds this information. So let's call this GameState RTS table. And then saying that we have a... Now, I don't know if the syntax is the same for CA65. I think this is probably CA65 syntax. We'll find out in a minute. So the load title screen -1. And remember, it's -1 because when we jump back, the RTS is going to jump back to that address, and then the program counter is going to immediately increment, so it's going to become the address that we actually want to be at. So we have to always remember that we're doing a -1 for the location we're jumping to. So that's it. See if that actually builds and doesn't give us any complaints. Header, segment header overflows memory area. This is because, because this is actually technically code, not header information. Let's create a new file. We'll call this GameState RTS table, because I'm really feeling creative tonight. Okay. All right, so that didn't complain. So that's the subroutine for loading the title screen in that table. So now the next part is, this is the part that's a little tricky, I think, and could be confusing. So the way that the code has to be written to actually execute this trick is you have to jump into a subroutine using JSR, but then you're effectively you're doing that only because you need to know how to get back to the code that's using this trick. Like, you could just, if you just went into this code, right, and executed this push of these two bytes onto the stack and then executed RTS, that part would work totally fine, right? Because you push the addresses, the 2 bytes of the address onto the stack, you use RTS to do the return. The program counter goes to your subroutine. In this case, it would be load title screen, right? It would execute whatever it's doing, and then it's going to call RTS. Now, this is where we're going to run into a problem. If you didn't call JSR to do this bit of the code, let's say that was the only function, that was the only, you weren't inside of a function call. This was just inside, like, the main execution body of your code. Well, there's nothing on the stack then, because the RTS that got called here removed these 2 bytes from the stack in order to go to this, and now you're going to call RTS on data that's not there. Like, there's nothing in the stack anymore. So that's obviously going to be a problem, because you're going to jump to potentially either, a random place, or to, memory address 0 or something like that, right? So that's going to be bad. So we have to make sure that we use JSR to actually invoke the code that's going to use the RTS trick, so that when we're done here, this will bring us back to here. So we'll create another file for this, and we'll call this GameState launcher. And we'll have a label for it. Oh, we'll do, I forgot about that. Okay, so the first thing we want to do is we want to load, it's just GameState into A. We want to transfer A to X because that's our index. So then we're going to load, it is the table +1 first. So we're going to load A, GameState RTS table.asm, no, not ASM, just GameState table +1 X, right? Because X is going to have our GameState, and that GameState correlates to a position in this table. And then we're going to push that into the stack. Right? Am I doing this right? Yeah. And then we're going to load GameState RTS table, and we're going to use X, and then we're going to push that onto the stack. And then, yeah, and then we're going to call RTS. So like, this is it. This is the code to do what we want to for something like this. So I'm going to comment out, let's see. So I have this code here that's doing some of these checks, and then if there's an issue, it just loops infinitely. So let's do this. Let's comment this out, and then I guess it's like a bad name for it. It really should be like process GameState. It's probably a better name. Where's the file here? Let's I mean, it is a launcher, but that's what we're really doing. That's a better name for it. So let's include that. So we're just going to say process GameState. we're going to add one more thing into here because just loading the title screen is kind of going to be boring. So let's actually have it process the title screen code. So here is our title screen code. And then it is going to... That's this. And what we want to do is after we process this, we want to jump to, what is it? Wait for draw to complete, right? So let's create code here. Title screen. And so this is going to, this is all now within its own scope, so it doesn't need to be scoped like that. We do want to do an end proc, and we also want to do an RTS to return. And this is just process title screen.asm. We can actually just call it process title screen, really. And then our table has to get updated. So we have word.world process title screen -1. And then, and I'll step through this code so that like we can actually see it in process here. Yeah, so that's the idea, is to break it out into its own subroutine file and then include it. We may end up in a situation, I probably will, that we want to start maybe creating some folders to better organize these files, because we're starting to get quite a few of them. 172. Process title screen.asm. So let's just make sure this all looks good, and that none of it is... Okay, nothing is jumping outside of this code to anything else. So process title screen. All right, so this code, oh, that's okay. So process game state, and we have that, and we're jumping to that subroutine. So process title screen is already defined. Let me see. Process title screen 97. There you go. What's the problem now? Title screen state. Oh, right. So this can be eliminated because we're not doing the check that way anymore. Game state RTS table not defined. Process game state. Is it just an order thing? Game state RTS table. Oh. I guess that wouldn't matter. What? Game. Oh. Come on. Sorry. I don't know why I did it that way. I like it better with multiple separation there. All right. So this may not work. That's okay. Let's just see what's going on. It'll be useful to debug and step through it regardless. So it's actually doing something that's close to the right thing, so that's good. Let's take a look. Come on. So process game state. So we're going to break right there because that's what we're kind of interested in looking at. So the stack is over here. You can see that it's FF right now. And as soon as we hit F11, we've got 2 bytes in here. And those 2 bytes are the location of the code that called the JSR. So now we're going to load game state into A, and we're going to transfer A to X. So it's 0, which is fine because in the beginning of the game, our state is load title screen. Where is it in constants? Yeah. So load title screen, right? Which is 0. So that's all good. So we're going to load GameState RTS table +1, which is 80, and we're going to push that. So you can see 80 showed up in the stack here. And then we're going to load 36, and we're going to push that. So now 8036 is the address. And if we go and we look at load title screen, that's 8037, so it's 8037 minus 1, so that's good. So what we should see is now when we go to the RTS call, process game state, our RTS is going to pop these last 2 bytes off the stack and then jump us over to the call to the code to process the title screen. And here we are, like magic. So that's what we expected to have happen, and then we have, like I was talking about, we have these 2 bytes that are in there from the RTS call to process the game state, right? That's the key part that you have to do so that it comes back to here to ensure that you actually get to this next instruction. Labels can be as verbose as is useful, right? Yeah, so labels just are syntactic. They just get turned into addresses. If you look at where is jump load background, so you can see that the address for load background is 8064 in that little window. I can't point, it moves with the mouse, so you can see it says symbol CPU address 8064, right? 4C is the instruction for jump, and then you have 8064, the 2 bytes that identify the location. And if you go to 8064 over here, that's where load background is. You'll notice that load background itself doesn't have an address, and that's because it's just syntax. It has no functional meaning. It's just a location that we're able to designate so that you have so that you as a programmer understand where you're going to without having to refer to it by address. You could totally do that. If you were an insane person, you could write your code where you're jumping to addresses. I don't know why you would ever want to do that, except in maybe very specialized cases where it's like one location where you know it's always going to be what you want to jump to. But like for just generalized coding, you would never do that, I don't think. All right, so if we then process our code here, everything should be kind of just as expected. We have this RTS, and sure enough, it brings us back to the jump for wait to complete, and the stack is clear, which means that everything was good there. So that's pretty cool. So what I want to do is the load title screen code. There is a point where once it's done, it switches over to title screen, which is here. So what I want to do is run until we get to that point. Oh, interesting. So it's not calling. Why is it not calling that? Load title screen. So it should be at some point, once it's done loading. Oh, did it do it already? And oh, no. See, look. See this? This is bad. This is bad. We're overflowing the stack quite badly. All right, so something else has gone wrong. Okay, so game state title screen. So it is changing the game state to 1, which is what we want. So the next time we go in and we process the game state, my guess is there's probably something wrong with the title screen code, that it's jumping out of the code. And then this is totally a guess, but if I had to take an educated guess, where I lost $5 because I bet somebody that that's what it was, and could potentially be wrong, but my guess is that the code for the title screen is jumping somewhere it shouldn't be, instead of using RTS, and that's breaking this. So game state is 1, that's our index. We're loading 98 and pushing it, loading 80, pushing it, and then so title screen, process title screen, 80, 98. So yes, so we would be coming to here. But why are we here again? RTS. Oh, that is not correct. Process title screen. Why are you that? I mean, that's the right address, isn't it? Process title screen, segment code 0, not code 9, code 0. That could potentially be it. All right, so load title screen, and we have our breakpoint there, stores it in game state. So now we return and we go to this, and I don't remember if there's a breakpoint in there, but okay, there is. That's okay. 98, 80, return. No, that's weird. Why is it jumping to that location? Process title screen. 8999. What is the location of our table? It is process title screen. Oh, why is there only one byte showing there? 8988. Memory viewer, please. 8988. We have 3680, 98, 89. So 8998. 8998. Process title screen. 8998. That is that code. Why is it not? Do I have? Let's see here. Let me double check that I actually rebuilt and reloaded this properly, because that's a little strange. Okay. So we set the game state, we return, go into this, we load 98, and then, oh, 80. Why is it loading 80 instead of 89? Oh, because it's not X, it's X times 2. That's why. Okay, that's a simple mistake to make. Let's go to the code here and fix that. Process game state. So load A and then ASL. Okay. So what was that all about? Well, remember, it's 2 bytes. So although X is the index into the table, you have to multiply by 2 in order to ensure that you are getting the right value, because I did not do that. And so we go back to the memory viewer here and we look at GameState RTS table that's at 8989. We have 80, 98, 89, 36, 80, 98, 89, which are the 4 values we actually want. But if you only increment X by 1, you get 80 and 98 instead of 98 and 89, which is what we need. So that's why that happened. That makes sense. I didn't think about that. Was that in the code here? No, because they, I guess, have a lookup for their value. Oh, no, they do. I just missed it right there. ASL. Okay. So, dumb mistake. That's okay. I figured I'd make some sort of mistake. Of all the mistakes to make, I think that's okay. Certainly not the worst mistake I've made. So we go into load title screen. And now we have, there it is, 89 and 99. And we execute that, and we are in process title screen. And so this is just going to keep calling that now, and we get the incorrect blinking. And then if I press start, it causes a problem because we don't have the methods defined. We don't have the table values defined for the other game states. So let's do that, because this is actually a good way to do it. There's a limited number of states, and so it makes it sort of more tenable and easier to understand. Now that, like, this is the cool thing, right? Like, so all this code here that was being executed is, you know, including like these checks here and stuff like that, that's all going away and becoming subroutines, we call, which is really nice. So the question was, is process title screen too vague? Wouldn't there be load title screen, then render title screen, as well as things like animate title screen, and other smaller functions? I mean, yeah, in this case, it's not really doing much, so I don't know that there's a need to, I mean, so process title screen is probably an okay, like, overall function name, and then within this you could have, like, you know, update, animate, render, something like that, where you break it down into smaller pieces, where if it's a really complex function compared to what we have right now. Does each level get its own state, or is there one loaded level state? There's one loaded level state. There's one, like, game running state. So it doesn't, you don't need one for each. There's this game play state, and then there's game pause. Let's do game pause because that's smaller, and should be easier to implement. It actually has, so, like, this is the thing, like, this is already broken into a subroutine, so we can very nicely move that into the table. I just don't remember what paused is for, so what we'll do is 0, 1, keep writing world because I'm tired, 0, 1, 2, 0, 1, 2, 3, and 4. So this is process pause -1. So we have that now. And so process pause is already implemented, which means that we can get rid of that, which means that we can get rid of pause state. Okay. let's say proc load new game and proc. So this is going to do all sorts of initialization, and that's already got. Wait, I already got that. Load new game state. Okay, well, see, I'm already ahead of the curve here. Load new game state. Totally forgot I even did that. Load new game state is going to go into 2. So now here we can get rid of this. Thinking about the pause state, you could replace a row of your tiles to display a pause message, or you could... Yeah, of course. I mean, right now it's just literally just sitting and looping and waiting for you to hit the start button again to unpause. But yeah, at some point that'll become more complex and allow you to do exactly what you're saying, you know, by swapping tiles in and out or something like that. All right, so load new game. Did I already make that a subroutine? Load new game state. Jump, bump, bump. Where did that go? Oh, it's here. So this is already a process. So yeah, load new game state, process game state. Oh, okay. Sorry. Yeah, I guess I'm more tired than I thought. Local gameplay state, wait for draw to complete, that's fine. Wait for draw to complete, and then this is, so this is all, so this is our gameplay state. Segment code 0. All right, so we can get rid of that label, and then this is going to be our sort of single biggest method we have, or function we have, and we'll have to, subroutine we have, and we'll have to kind of break this down into smaller ones. But what we're going to see is, what's nice is this should jump gameplay state. Why is that looping all the way back around? Swap to repeat control. Oh, because it's got a... Okay, that's fine, but we'll fix that later. Process player input. Yeah, so this is going to be huge, but it's going to make the main... file a lot cleaner. But yeah, this is going to be kind of a mess. So, and then we actually don't need to do that jump, but we do need to paste all of this code now in here. And this is proc process game play state and end proc and RTS. So that's going to be a little confusing. I will need to potentially rename that. That's game state, process gameplay state. Maybe we'll rename this to just process game. just use fewer words that are similar to differentiate. This needs to be able to jump back. So there's that. This also needs to jump back. This is just jumping back to the beginning of the subroutine, basically. There's our RTS. This feels like it's going to get really... That's going to get a little hairy. But what you can see is that's dramatically reduced the size of this file, because now we're just calling that subroutine to process the game based on the current state variable, right? So include process game and that's process. All right, I'm shocked that that actually built. Okay. And like magic, it worked. And pausing worked, and unpausing worked. So if we go to our code that processes the game state, we will see that it is constantly basically pushing values onto the stack and then returning to based on what the game state is, right? So process pause, because the game is currently paused. So that is cool. We're gonna remove that breakpoint, and I'm gonna unpause. And if we put a breakpoint here and we go to RTS, now we're processing the game, and we're in this huge loop. Yeah, so that is actually all working really nicely. Oops, I refreshed the Discord chat. Sorry about that. All right, so this is good. And if we go to the tools, now what we should see is all the new stuff we added. So we can sort by average cycle count. And so clear object entities is the big one, it looks like, although that was only done once. So we can ignore that. NMI, I mean, you know, it's NMI. We got to do stuff. Update controller. Like all of our normal stuff is actually relatively kind of mid-tier performance-wise. It's not really taking up too much. If you look at the percentage of time it takes, it's less than 1%. Let's go back and just make sure everything is processing and handling the way that it should be. Everything looks good. I don't know why I have a breakpoint there, but okay. Ugh. So the fact that I can still fire is a problem that we had before that's not related to this new code. I just want to check that the transition to the map is still working. It should. I don't see any reason why that would be problematic. Yep. Yep, so we're back on the map, and there is the actual little island code tile set that we put in there. So that's all working. So yeah, all of that stuff is actually looking good. So yeah, this definitely is helping, right? Like, so now when we go to, I mean, I'll answer your question more directly in a moment, but like, if you go look at the code, there's a lot less just kind of loose assembly here, and the game the game loop is now just literally this. It's update controller, process game state, wait for draw to complete, right? And the only reason I'm keeping that out of a subroutine is because it seems just kind of wasteful for us to do that in a subroutine where we're just kind of tightly looping, waiting for NMI to finish executing before we start going and updating any of our existing structures or anything. Once we've processed the game state, we have to wait for the frame to render before we do anything else. But yeah, like this is the whole thing, which is really simple to work with versus that huge bunch of code that we had before. Now, obviously, we just moved that into here. But now that we've kind of proved the concept of having this RTS lookup table, or the address lookup table with the RTS trick, we now have the ability to start doing the same thing with the code. Where is it? The code here. So we're gonna, this will substantially reduce this code here. Like we're talking about 522. I mean, 100 lines of code in a 650 line, 648 line file. Not bad. I mean, it's a pretty decent chunk. I mean, the main thing is we've reduced this. It was over 1,000 lines of code, more probably. We've reduced this down to a much more concise file, and we can do the same thing here. You know, both by moving things. I mean, a lot of this is already moved out, right? Like, so player bullet, the way I'm doing this, I'm just, you know, it's just the code is here. If I make this a subroutine and we include the file, and then we use the same process we were using for the other stuff where we generate this lookup table, right? Then we have a much simpler structure to work through with the entity tables and the projectile tables, and then it's not, we're not beholden to including the assembly files in the middle of the file because that's where it's actually being called from. It kind of breaks them out of that. And then the other thing is, and now I kind of understand what Felipe was talking about when we were discussing this better than I did at the time, because I wasn't really thinking about this, but it makes total sense now. Now that these things are subroutines rather than just code that's embedded, there's if the naming is kept consistent, then we can actually generate, I believe this is what he's doing too, we can generate that lookup table based on the naming. Like we have another one for entities and projectiles, and then the naming, as long as it's consistent, means that the file, as long as the file is there and included, then that's nothing I have to manually update ever again, right? We'll have an include that includes all of the code for the entities and projectiles automatically, and then we generate the table of lookups automatically, which is really, really nice. Logically, in an OO thinking, the game process and the projectiles is used in multiple levels and for multiple enemy types, so the same code works. Yeah, and I mean, and that's how this is being written anyway. Like, you know, nothing is really specific about the way that this works for this particular one level. But the way the code is kind of, the way I've bandied the code about a little bit has been less than ideal. And so when he and I were talking about this, I mean, I got the point of, like, you know, how the organization really helps things, but like I hadn't really fully understood the impact it could have on, you know, even the way the tool works and exporting things. So like to we can manually do this right now and then have the tool actually generate this, right? So we can have a file that we include that includes a bunch of files, right? And so what I want to do, as cool as that is, maybe we have a folder for like entities and projectiles. We'll call it, we'll just call it entities kind of generically. So, but then we have, what is it, process cloud. Where are those files? And that'll be in here. So it's just cloud ASM. So you can just actually look at this here. Cloud and LAP is definitely one of them. And explode is another. And spawn point is another. Could have been sorting my file from the very beginning. So spawn point, a little bit. Cloud, explode, palette swap, layer, camera counter. Right, so we can just move all of those into that folder. And then I think we have one. Yes, we have. Oops, we have it for the projectiles too. We have player bullet and enemy bullet. And like I said, I'm gonna move this into just one specific like entities folder. It doesn't need to be that broken down necessarily. LAP was, I believe, low altitude projectile. This is flyby. That was another enemy type. We'll just include all of those. And medium was one also. Projectile. Oh, it's a structure. Okay. So enemy stream. Okay, so that's another type of enemy something. I mean, none of these are really that important because they're all just like placeholders to some extent. But like separating them out is important, at least for the purposes of like demonstrating how this works and actually implementing this. You'd have enemy A, which includes projectiles and explosion, but enemy C may have explosions and evasion. Right. Yeah, I mean, that's exactly right. But the thing is, like right now, the way it works, if I add a new type, it's got to be, I've got to code it in here in order for it to work, rather than being able to include like this, where we have camera counter.asm and cloud.asm. Can I just do, I think I can. Just want to, oh, it's just going to open the files. Can I do this and get the names of the... No, that doesn't work. Trying to be lazy and not have to type these all out because I don't like doing that just in case I make a mistake. I can do that. Right, and so all of these potentially correlate to some sort of thing we're going to have to deal with in the game. Now, ideally, these have been, like I said, generated by the tool. So this would be like what would we call this? Entity logic, or entity includes. And then here we say include, entity includes. This is going to create some problems, but let's, yeah, okay, cool. So the problems are not what I thought I was going to create. The problems are the old code is looking for stuff that's no longer there. Process game code can then include entities.asm, and you add a new entity to that as you make them. Well, it's even more so, yes, but like my thinking is like I've got this project file and I've got these entities, and so I want to add something new called, boss1. And so then the idea would be that it would just include something called entities/boss1.asm here, and then also create the lookup for the code that handles boss1 in the table automatically, which we'll get to in a second. It requires being consistent in the naming and stuff like that, but that's actually really cool and worth the, that trade-off of doing that, I think. So this code, all right, so this is, yeah, so all this code is not going to work now because it's looking for stuff that's no longer there. So we have the entity includes, and then so what I want to do is I want to create a new file, which is going to be our entity lookup table. And again, this is something that we should be able to actually generate now. Segment code 0. But I'm going to type it out by hand for the sake of what we're doing here. I guess I should be consistent with the way I define the naming for the table. So GameState RTS table. So we'll call this entity RTS table. And then we just would go down the line of like how these are defined. So there's explode. So it's like process explode -1, except this is word process explode, right? And we can just actually steal, except that process bullet, process player, process cloud, process enemy bullet. Process a little bit. So the only thing that we don't do here that's a problem is we don't differentiate. We don't differentiate projectiles versus non-projectiles. So what we would need to do, and this is purely because I chose to split this up because I wanted to be able to represent them separately. So we're talking about doing this, right? So again, there's going to be some fixing up that we have to do. make this work, but that's okay. Eventually the tool will generate this. This is the I don't know what I would call this. Entity logic.asm, maybe? Something like that. Oh, well, entity logic tables. Something like that. I get so caught up in naming sometimes. And so, sometimes it's just better to just let go, and you'll think of a better name later. Usually it's not too big a deal to rename it. As long as it's not something completely stupid or contrived, you'll be okay. So projectile RTS table. And then it's just bullet. I wish I would stop writing world, process, enemy, bullet. Okay. So that's that, and then let's see. So entity includes and entity logic tables.asm. And then we need to make sure that all of these are now procs. So this is going to be a little bit of a challenge here. Let's leave this one. I got to think about this a little bit more. Let's go to the ones that are a little bit more straightforward, although they will all at some point have this problem. So I can't just ignore it. This is just a RTS now. The bigger problem is this clear object entity. Really should just be a subroutine now instead of part of the code. Clear object entity. So this should really just be, I mean, and that's fine because ultimately, like, that's probably the right way to do it anyway. Instead of jumping to this, we can call it. So there's our code for that. This is just going to clear stuff out, and then what we would do is we just say jump to that subroutine and then exit when it's done. So we need to include clear object entity.asm. Right, so that's the cloud. This should be now process cloud because that's what it's expecting it to be. And then proc. Okay. And then this is just an RTS. This should be really a call to jump subroutine to clear clear object entity. Except did I rename this like I thought I did? It's just a lot of like reshuffling things around. So camera camera enemy bullet proc process enemy bullet, and then RTS, and this is JSR clear projectile entity, so that's going to be something new that we have to introduce. Enemy bullet done. Done. This is going to call clear projectile entity and then RTS. This is going to same thing. So JSR clear projectile entity and then RTS. All right, so that is almost done. Segment code 0. Enemy stream. So actually shooter.json. I don't have enemy stream included anymore, so I'm going to ignore this one and not include it here. Definitely still use explode. RTS. So this is processing the. This is just processing the animation for the exploding that happens when you destroy an enemy or you yourself get destroyed. That's pretty much it. So that's good. Flyby. We're not using that anymore, or we're not using it currently, so we'll just remove that. Same thing with that. I wanted the files still there, but I'm not gonna change the code because it's not important right now. This should be. Did I forget to do? Shoot. Did I forget to do that? I did forget to do that. So, process. I had two problems with that one. Explode. Oh, they're all capital here. Process little bit. This is just that now. And proc. This is RTS. This is jumps routine clear object entity. RTS. Clear. So before we were just jumping to this clearing of the object entity, but now it's got to be its own subroutine, right? That's what we did. And then you're just RTSing out because you're done. Before, when you jumped, you didn't have to do the RTS or any sort of other return because it naturally, the code flow just naturally went to the place that it had to. So it adds a little bit of complexity there, but that's okay. That's an anonymous label that jumps to that. Okay. We're good with little bit. Explode is good. Let me just go back to cloud for a second and just double check. Yeah, that I think I was doing that consistently up until that point. palette swap. Capital P, capital S. So let's do this the right way. So have it clear itself when it's done, which is good. All right, so, and then camera counter. We have player bullet. I think I did camera counter, right? That was one of the first ones I did. Except that it should be process camera counter, like that. Bullet, enemy bullet. Oops. So this is process bullet. So this is all kind of like just mechanical work here, which means that I may end up messing it up accidentally, but we'll see. Hopefully not. Enemy bullets. Process enemy bullet. It did the thing already. Yeah, I guess that was one of the earlier ones I did. This should be just process player. This should be RTS. Player collided, turn into explosion. And then what is it doing? Nothing after that? Check collision loop. Just RTS from there because it's done. Jump collision loop. Where that? There it is. All right. I think that's all okay. Potentially. Oh, wait a minute. I keep forgetting the segments. Just so that I mean, it should be okay. But why take that chance? I did this one. Did those spawn point. Oh, I didn't do this at all. Okay. Okay. So that is good. And then one thing we didn't do is we did not create clear projectile entity. Oh, wait. Did I actually implement that already? Interesting. Okay, so clear projectile. Oh, right. I think I said I should implement this because at some point I'm going to need it. And then totally forgot I did it. But this is actually slightly different from Oh, that's clearing all of the projectile entities. Oh, it's pluralized. Okay. So this just clears the one. So we're gonna do this, and then we're gonna get rid of that. We're gonna leave that. Skip projectile entity. Oh no, that's not what you were supposed to do. Projectile entity. Oops. That's that. Clear projectile entity.asm. Which is again segment code 0. That may eventually have to change, but for now it's okay. So that's this. Yeah, we're really kind of like ripping everything apart right now. Clear object projectile entity.asm. And this actually is correct. So that's good. And clear object. Clear. Okay. I guess I must have. Include. JSR. This is not correct anymore. Oh, but that's enemy stream. I don't care about that. Flybot, I don't care about that. A little bit. I do want it to call that JSR. Don't care about that. This is JSR. Branch of equal. No. This should be JSR return. Oh, actually, wait a minute. Branch of equal to that. So what I really want to do, is actually this. I want to JSR that, and then RTS. Okay. So, yeah, so that's clear. That gets cleared out. That was one area that was wrong. This is going to be a complete mess now to build. But I want to look at the errors we're seeing to make sure that they are all logical errors. Entity, logic tables. Oh, yeah. I don't think you need the commas, buddy. Constant expression expected. Shooter.asm. 141. Size of entity. 144 projectiles. Where? Why this constants should be included up higher is so constant expression expected 141. But what are you referring to? Size of entity, that's a and so is that. A feeling it's something else. Entity logic tables. Entity Logic tables, that's code 0. Code 0. Maybe it's something in this, because now we have all these include files that don't really, these .inc, or the includes that don't make sense anymore per se. Let's comment these out because they're not meaningful anymore anyway. This one is okay in theory. Draw sprites. Okay, so that's better. Constant expression shooter.asm. What am I missing? Cannot open include enemy bullet. It must be an old. Let me. Can you clear the terminal? Output. Yeah. Okay. Constant expression. Okay, so we're back to just this in this file. Could having .inc be useful for includes that only include ASM or assets and are not code files? Yeah, there's definitely value in being able to use them. I just, right now I'm moving away from it because it was basically just kind of like injecting the code into the source, so it didn't really make a whole lot of sense in that particular way I was doing it. I mean, it was fine, but it's not as organized or clean as what we're trying to accomplish here. So both of the issues are related to this. It's not something like, did I, no. Constants, U-bound, entities, size of, okay, and then I'm a little baffled by why it does not like this reservation. If I say like 5, does that get rid of that error? Yeah, so something about max entities being in this constants file. It's kind of weird. Should this just be an inc? What did that do? Oh. Oh, because I'm thinking inc bin. Never mind. So, yeah, this is just importing these constants, but they're not code. I mean, does this need that? It shouldn't need that because they're definitions. Yeah, so why are they somehow out of scope? Segment RAM. Weird. It's weird that it's not, like, if I just move, I assume that if I just move this to, like, here, like where it kind of was before. Oh, well. Yeah, good work, genius. Try this. Oh, 152. So that's not working. entity.asm. Why is this getting confused? Constant expression required. Am I missing something obvious here? We have the objects we're reserving a size. That's size of entity times max entities. Doesn't seem to like this. I thought you don't need this, right? Yeah, it definitely doesn't like that. I didn't think you needed that because it was working fine before. Is it something to do? Let's see. Is it something to do with these files here? Process game undefined. Okay. I mean, so far all of that is pretty reasonable. It's weird. Clear project and projectile entity is already. Did I include it somewhere else? Oh, I did. Oops. Okay. Well, that wasn't it. Constant expression. Like usually you'll see that where something like the value wouldn't be determinable until runtime, which is not possible for what it's trying to do here, but it is a constant. I mean, I'm literally just, you know, writing it in. Like if I did this, yeah, it's not unhappy with. Is it some sort of syntax thing? But like, why is that? Why didn't it like that? And then we have a whole other issue of now this is going to break other stuff, or other stuff is not happy. So 536 local scope not closed. Whoa, something is not okay. So maybe this is a side effect of some other issue. Entity logic table. That's the definition of those two tables. That is nothing different from that, so that looks okay. It could be something else, like some sort of issues with the code that's in here or in all of those functions potentially. Weird that it is stopping on this file because of something like that. Let's fix these other problems, because it seems like there's a lot of other issues here that are not getting captured because of that constant error that it's complaining about. So all this is fine. Note expanded from here. Process game 101. I don't know what that means. It's Y83 temp. I mean, that should just be... Shouldn't matter. That didn't matter for any of the other variables, so that's weird. Segment code 0, proc player. Dropping 13 additional line infos. Symbol lookup is undefined. Process game. These are all variables that should be okay. Like something else has gone really messed up here. So it could be that there's some sort of syntactical problem with the files that I included at the top, and that's causing the assembler to get confused. So let's start with clear object entity and just like make sure there's nothing obviously wrong here and with any of the other. Okay, so that's fine. Entity includes, and then we're gonna do camera counter. So we're gonna walk through all of these and make sure everything looks good. I was kind of doing them very quickly, not really thinking through too much, so it's possible that there's some sort of issue with what was written. Branch carry clear to there, branch of equal to there, JSR, so that all looks clean. Enemy bullet, proc process enemy. Oh, here we go. So this is going to be a problem. No end proc. That definitely would cause potentially some of the problems we're seeing where the assembler is confused. Let's just double check all of the rest of them for the same kind of problem. Proc, there's the end proc. There's proc, there's end proc. Proc, end proc. Proc, end proc. Proc, end proc, great. That will hopefully fix issues we were seeing with this giving nonsensical errors about it not being constant. Okay, yeah, that went away. Draw sprites, no reference on, yeah, that's normal. Symbol entity object complete is undefined. Player.asm, entity object complete, yeah, this is return. And this is, yeah, this should be processed. So, this code has the movement data encoded right here, which is actually, I was not paying attention. Okay. See, it's a good thing this error came up. So little bit movement. So this is just data. I was not reading this correctly, so this should be a little bit movement. Okay, so that should fix that. Process bullet. Where is it looking for that? Process game. 585. Okay, yeah. So these are all the places now where things are wrong because of the fact that we've kind of reorganized all of this. I really need to stop. I'm really running out of steam here, so we're getting close. We'll be able to finish this up next time. We made a lot of progress, moved a lot of stuff out. We have a better appreciation for this because is going to help really clean up all this code, and we will be able to do some work around the other code that's around this process game method, function, subroutine, whatever you want to call it, because there's a lot of stuff going on here, especially related to scrolling, that we could probably break up into steps. Nothing else, we could, you know, break it up into a couple functions, for one for processing the standard scrolling, one for processing the repeat scrolling, and so on and so forth. But we'll see kind of how that works. So as always, thanks for tuning in. If you want to reach me, I'm on Twitter at Clearvis. I am on Video Game Sage as Xelius, Xelius. You can email me at xelius@gmail.com. Feel free to reach out to me in either way. I'm on Discord as Clearvis or Xelius on Video Game Sage specifically. Feel free to ask questions or make comments on the video recording on YouTube below the description. Thanks, Scow. I will definitely get some rest. I need it. Thanks, everybody. Yeah, and just check out, I've got a Patreon if you're interested. I've got a buy me a coffee if you're interested. Totally not necessary if you're interested in seeing this source code. I've got to update. I'm going to update that soon once we get this working, so people can see the new code organization. If you're interested in seeing that, you can pre-order the game on itch.io. And that will get you access to the core source code of the game, and you can take a look at it yourself. And then eventually you'll get a ROM once I'm done. So yeah, I can't even finish this outro. So thanks for watching. Have a great weekend. Have a good night, everybody who's on the stream. Thanks for joining, and I will see you on Monday. We're going to switch to 9 o'clock again, which is what I was doing originally. And as late as that can get, it's really hard getting myself organized to stream at 8 with dinner finishing up and kids being put into baths and going to bed. So I'm going to switch back to 9 o'clock. It was a nice experiment, and it was nice finishing earlier, but it is just not practical. So see you Monday at 9. Have a good one. Thanks a lot. Take care.